Hello everyone, this is Shreya Chakravarti holding USN of 1VE 21CS163 is here to present a slideshow on the topic exponential distribution from the branch Computer Science and Engineering. Introduction. The exponential distribution is a continuous probability distribution in probability theory and statistics. It is defined as the probability distribution of the time between events in a Poisson point process, where events occur continuously and independently at a constant average rate. In this slideshow, we are about to discuss the contents here. What is exponential distribution? Formula for exponential distribution, mean and variance, exponential distribution, graph of exponential distribution, and application. What is exponential distribution? In probability theory and statistics, the exponential distribution is a continuous probability distribution that often concerns the amount of time until some specific event happens. It is a process in which events happen continuously and independently at a constant average rate. The exponential distribution has the key property of being memoryless. The exponential random variable can be either more small values or fewer larger variables. For example, the amount of money spent by the customer on one trip to the supermarket follows an exponential distribution. In probability theory, as we have prepared a slide on it, in probability theory, the exponential distribution is defined as the probability distribution of time between events in the Poisson point process. The exponential distribution is considered as a special case of the gamma distribution. Also, the exponential distribution is the continuous analog of the geometric distribution, as we have previously discussed about it. Here comes the formula for exponential distribution. The continuous random variable, say x, is said to have an exponential distribution if it has the following probability density function. Here we are given with the function and the condition where fx of x is lambda e to the power minus lambda x, where the condition is x should be greater than 0 and 0 otherwise. The exponential distribution graph is a graph of probability density function which shows the distribution of distance or time taken between events. The term used in exponential distribution graph is lambda, as it is presented here, and x. Here lambda represents the events for unit time and x represents the time. Heading towards the next topic, mean and variance. First we will go through what is mean. Mean is basically a rapid growth or in an extent or a size. The rapid growth rate is depicted as mean, where the mean of an exponential distribution is calculated using the formula Ex is equals to 1 by lambda. The mean or expected value of an exponential distributed random variable x with the rate parameter, where the rate parameter is lambda, is given by b, and the formula is given as shown in the slideshow. Ex is equals to 1 by lambda, leading towards the next subtopic, that is variance. What is variance? Variance is to find the variance of an exponential distribution. We need to find the second moment of an exponential distribution. Hence, variance of a continuous random variable x is calculated as variance of x is equal to ex square minus ex whole square. Here, in light of the examples given below, this makes sense. If you receive phone calls at an average rate of 2 per hour, then you can expect to wait half an hour for every call. The variance of x is given by variance of x is equals to 1 by lambda square. Will be leading to the applications of exponential distribution. Here are the few points written below. First is predict the time when an earthquake might occur. Second, lifespan of electronic gadgets. Third, establishing a new shop. Fourth, shoppers at a shopping mall. I'll be describing each point through. First, predict the time when an earthquake might occur. Predict the time when an earthquake might occur. The exponential distribution is prominently used by seismologists and earth scientists to predict the approximate time when an earthquake is likely to occur in a particular locality. For this purpose, the history of the earthquakes and other natural calamities occurring in a particular locality is recorded and monitored. This data acts as an information and is fed to the exponential distribution function. The output gives an approximate time when the earthquake might occur. This helps the environmental engineers and disaster management officials draft the essential measures to avoid the loss of lives and to minimize the property destruction rate. Heading towards the next topic, that is lifespan of electronic gadgets. Exponential distribution finds its prime application in calculating the reliability of electronic gadgets such as laptop, battery, processor, mobile phone, etc. It helps the engineers and manufacturers to know an approximate time after which the product will get ruptured. The engineers use this data to improve the quality of their products by replacing the low quality components with those having comparatively high quality. Basically, these are used to just increase the lifespan of the gadgets so that the gadgets can be used highly in a good state and for a long run. Establishing a new shop. While establishing a new shop, a person tends to consider a variety of factors that may affect his or her business. One of such key factors is the number of customers arriving at the shop during the first week. For this purpose, the entrepreneurs make use of exponential distribution to roughly estimate the number of customers expected to visit the shop on the inauguration day and on the following days. This helps the shopkeeper keep an appropriate amount of products ready to serve all of his or her customers. This exponential distribution also helps to predict the time duration between the arrival of two consecutive customers. The last point goes with shoppers at shopping mart. Here, the shoppers at a shopping mart are a prominent example of situations where an exponential distribution is followed. This is because most of the shoppers tend to spend a small amount of money on the products, which only a few of them spend a large amount of money. Thanks for visiting my channel. Hope this video was informative enough. Please do like, share, comment and subscribe.